Hello everyone. Today I am going to discussing about the how to solve the linear programming model by Simplex method. I will explain this method by one example problem. Let's see the problem. Use the Simplex method to solve the following linear programming model. Maximize z equal to 3x1 plus 2x2 subjected to constraints 2x1 plus 2x2 less than or equal to 40, x1 plus x2 less than or equal to 24, 2x1 plus 3x2 less than or equal to 60, and x1, x2 are greater than or equal to the 0. Let's see the solution. First, observe the given problem is a maximization or minimization problem. Here the problem is maximization model. If the given problem is maximization model, there is no need to change anything in the objective function, that is z equal to 3x1 plus 2x2. Next step is convert the inequality of the constraints into a equation by introducing the slack variables s1, s2 and s3. After observe the objective function, next we have to observe the given constraints. Here three constraints are given, that is 2x1 plus 2x2 less than or equal to 40, x1 plus x2 less than or equal to the 24, and 2x1 plus 3x2 less than or equal to 60. Here all the three constraints are having the less than or equal to inequality. So we have to introduce the slack variables in the constraints to convert the constraint equations. See here three constraints are there, so we have to introduce the three slack variables, that is s1, s2 and s3. Here we are introducing the s1 slack variable in the first constraint and s2 slack variable in the second constraint and s3 slack variable in the third constraints. Then our constraint equations are 2x1 plus 2x2 plus s1 equal to 40, x1 plus x2 plus s2 equal to 24, 2x1 plus 3x2 plus s3 equal to 60, and x1, x2, s1, s2, s3 all are greater than or equal to the 0. After that one, next we have to write the objective function in the terms of the all the basic variables, that is maximize z equal to 3x1 plus 2x2 plus 0 s1 plus 0 s2 plus 0 s3. Next step is find the initial basic feasible solution. We will get the initial basic feasible solution by assuming the value of the decision variables are 0, that is x1 and x2 are equal to 0, and substitute these values in the constraint equations. Then we will get the initial basic feasible solutions. That is, so when the x1 and x2 equal to 0, that is s1 value will become the 40, then s2 will become the 24 and s3 will become the 60. Next step is write the standard form of LPP into matrix form, that is AX equal to B matrix form. Here A is the m by n matrix of coefficient of variables for the constraints equations. Next, X is the columnar matrix of the basic variables, that is x1, x2, s1, s2 and s3. And B is the columnar matrix of the right hand side values of the constraint equation, that is 40, 24 and 60. Then write the matrix form. First write all the basic variables, that is x1, x2, s1, s2 and s3. Next observe the first constraint coefficients, that is 2, 2, 1, 0, 0. So first observe the first constraints. First constraint coefficients are 2, 2, 1, 0, 0. In the first constraints we don't have the s2 and s3. So coefficients for the s2, s3 are the 0. Next observe the second constraint equation, that is x1 plus x2 plus s2 equal to 24. Here coefficients for the x1 and x2 is the 1, 1 and coefficient of the s1 is the 0 and coefficient for the s2 equal to 1 and coefficient for the s3 is 0. Similarly, we have to observe the third constraint, that is 2x1 plus 3x2 plus s3 equal to 60. Here coefficient for the x1 and x2 is the 2, 3 and coefficient for the s1 and s2 is the 0 and coefficient for the s3 is 1. Next we have to write down the columnar matrix of the all the basic variables, that is x1, x2, s1, s2 and s3. Next B is the columnar matrix for the right hand side values of the constraint equation, that is 40, 24 and 60. Next step is construct the initial simplex table. So this is the initial simplex table. Here Cj is the cost coefficients for the basic variables which is obtained by observe the objective function, and Cb is the initial cost coefficients for the slack variables. B is the basic slack variables. Xb is the initial basic feasible solution for the basic slack variables. First fill the cost coefficients for the basic variables. For this observe the objective function. Our objective function is z equal to 3x1 plus 2x2 plus 0s1 plus 0s2 plus 0s3. Here 3 is the cost coefficient for the x1 decision variables and 2 is the cost coefficient for the x2 decision variables and 0 is the cost coefficient for s1 basic variable and 0 is the cost coefficient for the s2 basic variable and 0 is the cost coefficient for the s3 basic variables. So first we have to fill the all the Cj values. So for x1 it is the 3, for x2 2 and s1 0, s2 0, s3 0. And next to write the initial basic variables, that is s1, s2 and s3, and fill the initial cost coefficient for s1, s2, s3. That is, here I have to observe the objective function 0 s1. So 0 is the cost coefficient for the s1 variable and 0 is the cost coefficient for the s2 variable and 0 is the cost coefficient for the s3 variable. So Cb values are the 0, 0 and 0. Next fill the Xb values, that is initial basic feasible solution values, that is 40, 24 and 60. Next fill the remaining values by observing the coefficient matrix, that is A matrix. So here values of the matrix A is the 2, 2, 1, 0, 0 and 1, 1, 0, 1, 0, 2, 3, 0, 0, 1. So I have to fill these values here. Next step is calculate the values of Zj minus Cj and check the basic feasible solution for optimality. First we have to find the Zj minus Cj. We know that one Zj minus Cj is equal to the CBxj minus Cj. So first we have to find out the Z1 C1 which is equal to CBx1 minus of C1. So CB into x1 will become 0 into 2 plus 0 into 1 plus 0 into 2 minus C1 mean minus 3. So total value of the Z1 minus C1 is the minus 3. Next Z2 minus C2 equal to CBx2 minus C2. So this is 0 into 2 plus 0 into 1 plus 0 into 3 minus C2, this means minus 2. So which is value will become minus 2. Next Z3 minus C3 equal to CBx3 minus C3 which is equal to the 0 into 1 plus 0 into 0 plus 0 into 0 minus of C3 that is the 0. So total value will become the 0. So next Z4 minus C4 is the CBx4 minus C4. CBx4 will become the 0 into 0 plus 0 into 1 plus 0 into 0 minus C4 mean minus 0. So total value will become the 0. Next final one is the Z5 minus C5 which is equal to the CBxy minus C5. CBxy will become the 0 into 0 plus 0 into 0 plus 0 into 1 minus C5 mean minus 0. So total value will become the 0. Next we have to check the basic feasible solution for optimality. Here observe the Zj minus Cj values. First condition is if all Zj minus Cj is greater than or equal to 0, the optimal solution will obtain. Second condition is if at least one Cj minus Zj is the negative, then indicated by arrow, and this column we are calling as the key column. Next third condition is if more than one Zj minus Cj is the negative, then we have to choose the most negative value of the Zj minus Cj, and this column we are calling as the key column. Here we are having the more than one value of the negative values for the Zj minus Cj, that is minus 3 and minus 2. Among this minus 3 and minus 2, we have to choose the most negative value, that is minus 3, and we are indicated by the arrow value, and this column we are calling as the key column. So respected most negative value column, that is the x1 column, we are calling as the key column, and also we are calling as the that x1 we are calling as the incoming vector. Next step is we have to calculate the minimum ratio of the xp divided by ck. Here ck is the key column elements. So first we have to find out the minimum ratio for the S1 basic variable, that is xb value is the 40 and key column elements are the 2. So minimum ratio of the xb by key column elements for the S1 variable is 40 divided by 2, which is equal to the 20. Similarly, we have to calculate the minimum ratio of xp divided by key column elements for the S2 basic variable, that is 24 by 1, which will give the value of the 24. So next we have to find out the minimum ratio of the xp divided by key column elements for the S3 variable, that is 60 divided by 2, which is the 30. Among these values, we have to observe the minimum ratio of the xp by key column elements. See here 20 is the minimum value. So this is we are indicated by the arrow, and this respected row we are calling as the key row. Here S1 basic variable row having the minimum ratio. So this respected row we are calling as the key row, and respected variable we are calling as the outgoing vector. Here S1 row having the minimum ratio of the xb by key column elements, that is respected row we are calling as the key row, and respected basic variable we are calling as the outgoing vector. Here S1 is the outgoing vector. So similarly, you have to identify the common element in the key row as well as the key column. See here, 2 is the common element, and this 2 we are calling as the key element. So next step is, once again we have to construct the new simplex table by entering this incoming vector. Next we construct the new simplex table by replacing outgoing variable s1 with incoming variable x1. So enter the x1 in the basic variable and write its cost coefficient value as 3 in the CB column. Here s1 is outgoing variable and its coefficients are the 1, 0, 0. x1 is incoming variable, so we have to make its coefficients also 1, 0, 0 by the following row operations. First row operation is R1 new equal to R1 volt divided by key element. Here key element is the 2. Second row operation is R2 new equal to R2 volt minus R1 new. Third row operation is R3 new equal to R3 volt minus 2 R1 new. So first we have to look for the first row operation, that is R1 new. R1 new equal to R1 volt divided by 2. So R1 volt elements are the 40, 2, 2, 1, 0, 0. So divided by 2 gives the R1 new elements, that is 40 by 2 equal to 20, 2 by 2 equal to 1, 2 by 2 equal to 1, 1 by 2, 0, 0. So these are the R1 new elements. Next we have to look for the second row operation, that is the R2 new equal to R2 volt minus R1 new. R2 volt elements are the 24, 1, 1, 0, 1, 0. And R1 new elements are the 20, 1, 1, 1 by 2, 0, 0. R2 volt minus R1 new gives the R2 new elements, that is 24 minus 20 equal to 4, 1 minus 1, 0, and 1 minus 1, 0, 0 minus 1 by 2, it is the minus 1 by 2, 1 minus 0, it is the 1, 0 minus 0, it is the 0. So next we have to look for the third row operation, that is the R3 new equal to R3 volt minus 2 R1 new. So R3 volt elements are the 60, 2, 3, 0, 0, 1. And R1 new elements are the 20, 1, 1, 1 by 2, 0, 0. And 2 times of the R1 new elements will become the 20 into 2, 40, 1 into 2, 2, 1 into 2, 2, 1 by 2 into 2, 1, 0 into 2, 0, 0 into 2, 0. And R3 volt minus 2 R1 new is the R3 new elements, that is 60 minus 40, it is the 20, 2 minus 2, 0, 3 minus 2, 1, 0 minus 1, minus 1, 0 minus 0, 0, and 1 minus 0, 1. So these are the new simplex table elements. This is the new simplex table. Once again you have to calculate the Zj minus Cj values, and you have to check the basic feasible solution for optimality. So first we have to find out the Zj minus Cj values.
We know that one Zj minus Cj equal to Cb Xj minus Cj. So first I have to calculate the Z1 minus C1, which is equal to Cb X1 minus of C1. See, Cb X1 will become 3 into 1 plus 0 into 0 plus 0 into 0 minus C1, which means minus 3. So this value will become the 0. Next we have to find out the Z2 minus C2, which is equal to CBX2 minus C2. See, CBX2 values will become 3 into 1 plus 0 into 0 plus 0 into 1 minus C2. C2 value is the 2. So this value will become the 1. Enter the 1 here. So next we have to find out the Z3 minus C3, which is equal to CBX3 minus C3. See, CB and X3 will become the 3 into 1 by 2 plus 0 into 1 by 2 plus 0 into minus 1 and minus C3. C3 value is the 0. So here Z3 minus C3 value will become the 1.5. So here we have to enter here 1.5. Next we have to find out the Z4 minus C4, which is equal to the CBX4 minus C4. CBX4 will become the 3 into 0 plus 0 into 1 plus 0 into 0 minus C4. C4 value is the 0. So total value is the 0. And finally we have to find out the Z5 minus C5, which is equal to CBX5 minus C5. CBX5 will become the 3 into 0 plus 0 into 0 plus 0 into 1 minus C5. C5 value is the 0. So final value is the 0. So I have to enter the 0 here. After determining the Zj minus Cj values, we have to check the basic feasible solution for optimality. Here I have to observe the Zj minus Cj values are greater than or equal to 0 or any are having the negative values. Here observe that one, these all Zj minus Cj values are the positive values only. So all the Zj minus Cj values are greater than or equal to 0, then we obtain the optimal solution. Here all Zj minus Cj values are the positive, so then we are obtaining the optimal feasible solution. And after getting the positive values of the Zj minus Cj, then we have to observe the what are the xb values for the decision variables. Here x1 and x2 are the decision variables which are given in the objective function. So x1 and x2 are the decision variables. So here we have to observe the xb values for the decision variables. So here we are having the only one decision variables in the basic variables column. So that value is the 20. So here x1 value is the 20 and x2 value is the 0. Then we have to substitute these x1 and x2 values in the given objective function. Then we are getting the maximum z value is the 60. Thank you.